We will look into two different approaches of saving a trained model to a file which you can use. We are going to continue our linear regression as here, but the thing that is different is this extra township column. Till now, we were but by the predictor function that can take with handling the numeric side. Think you are assigning numbers to these township axis arguments. 0.95, which means my model is 95% accurate. In this video, we are going to look into how to split your dataset into training and tests using sklearn train test split method. Usually when you have a dataset like this, accurate. In this video, we are going to look into how to split your dataset into training and tests using sklearn train. Sometimes we train, usually when you have a data set like this, sometimes we train the model using the entire data set, but that's not a good strategy. The good strategy is to split the data set into two parts, where you use part of the sample for actual training and you use remaining samples for testing your model. And the reason is you want to use those samples for testing the models that model has not seen before. So for example, here if I use the first 8 samples to train the model and then use the remaining two to test, then I will get a good idea on the accuracy of model because the model has not seen these two samples before. The dataset that we are using for this exercise is the BMW car prices dataset. Here I have the mileage and the age of the car and the price that it was sold for. So these are all the sold BMW cars along with their mileage, age and sell price. And here mileage and age are independent. This CSV file into a data frame which looks like this between my dependent and C points. Similarly for car age and sell price, I have plotted another scatter plot, and here also you can model based on these visualization. I have prepared my X and Y here. So X again mileage and age, and Y is the selling. Train test split method from sklearn.model selection. Use this method, supply X and Y as an input, and also you need to supply the ratio by which you are splitting. So here I want my test dataset size to be 20% and my training dataset size to be 80%. So this is how you specify that. As a result, what you get is a test. You get 4 parameters back, okay? And if you look at the length of whatever you got back, you will see it is 80% of your total data size. Your total data size here is 20, and based on 80% ratio, my training data set is 16 samples. Look at test and it will be 4, as you would expect it to be so. If you check the actual content of your X-train, you will see that it chose the random samples. It's not selecting the first 80% of the samples, it's just using random samples, which is good. If you execute this method again and again, you will see that the samples will change here. Now sometimes you want your sample to remain same, and for that you can use this random state method. If you use random state, remember it's gonna use same samples, okay? So for random states value of 10, it will always produce the same output. You can see that my X train is not changing now, right? 20 X train is not changing now, right? 22,500. You'll see these values are not changing when I execute this multiple times. Whereas if I didn't have this parameter, it was changing all the time. So if you do control enter, you can see that, right? Okay, now let's use our linear regression model, right? So you can guess that I create my client method to need to use X train, Y train, and my model is train now. And now I can call predict method on my actual test data set. So my model, let's say, so value accuracy. Okay, that's just because, see, so here accuracy is 0.89%. Okay, that's just because of the nature of my data set. But that's all I had for this tutorial. You learned that how train test split can be used to split your actual data set. So you can change your percentage ratio between the two data set by modifying this. If I do this, then it will be 70-30 ratio. Okay, so that's all I had for this tutorial. I don't have any exercise, but I have this notebook available in the video description below, so feel free to download it and play around it. Thank you. The goal of this tutorial is to solve a simple classification problem using logistic regression. If you have followed my previous tutorial, we have learned a lot about linear regression, especially the home prices example. Linear regression can be used to predict other things such as weather and stock prices. And in all these examples, the prediction value is continuous. There are other type of problems such as predicting whether email is spam or not, whether the customer will buy the life insurance product or person is going to vote for which party. All these problems, if you think about it, the prediction value is categorical because the thing that you are trying to predict is one of the available categories. In the first two example, it is simple yes or no answer. In the third examples, it is one of the available categories. Whereas in case of linear regression, the home prices example, we saw that the predicted value could be any number. It is not one of the defined categories. Okay. Hence, this second type of problems is called classification problem. And logistic regression is a technique that is used to solve classification problem. And logistic regression is a technique that is used to solve these classification problems. Now, in the classification examples that we saw, there are two types. So the first example was predicting whether customer will buy insurance or not. Here, the outcome is simple yes or no. This is called binary classification. On the other hand, when you have more than two categories, that example is called multi-class classification. Let's say you are working as a data scientist in a life insurance company, and your boss gives you a task of predicting how likely a potential customer is to buy your insurance product. And what you are seeing here is the available data, and based on the age, the information you have is whether customer bought the insurance or not. Now here you can see some patterns such as young people don't buy the insurance too much. You can see like there are persons with 22, 25, these kind of ages where 0 means they didn't buy the insurance. Whereas as the person's age increases, he's more likely to buy the insurance. So you know the relationship, and you want to build a machine learning model that can do a prediction based on the age of a potential customer. So as a data scientist, now this is the job you have been given. Now the first thing you would do when you have this data is you will plot a scatter plot which looks like this. When you have worked on linear regression problems already, the first temptation you have in your mind is you start using linear regression. So when you draw a linear equation line using the linear regression, it will look something like this. Now, how did we come up with this line? For that, you can follow my previous linear regression tutorials. If you think about it, what I can do here is I can predict the value using linear equation line and say that if my prediction, you have first thing you would do when you have this data set. So you know the relationship, and the young people where 0 means they didn't buy the insurance. Whereas as the person's age increases, he's more likely to buy the insurance. So you know the relationship, and you want to build a machine learning model that can do a prediction based on the age of a potential customer. So as a data scientist, now this is the job you have been given. Now the first thing you would do when you have this data is you will plot a scatter plot which looks like this. When you have worked on linear regression problems already, the first temptation you have in your mind is you start using linear regression. So when you draw a linear equation line using the linear regression, it will look something like this. Now, how did we come up with this line? For that, you can follow my previous linear regression tutorials. If you think about it, what I can do here is I can predict the value using linear equation line and say that if my predicted value is more than 0.5, so here this is 0.5. If it is more than 0.5, then I will say, okay, customer is likely to buy the insurance. If it is less than that, then he is not going to buy the insurance. So anything on the right hand side is yes, anything on the left hand side is no. Now, of course, we have these outliers, but we don't care about them too much because for 90% of the cases, our linear regression will work okay. Now imagine you have a data point which is far on the right hand side here. So say a customer whose age is more than 80 years, let's say he bought your insurance, okay? Then your scatter plot will look like this, and your linear equation might look like this. In this case, what will happen is when I draw a separation between the two sections using 0.5 value, here the problem arises with these data points. Actually, the answer was yes here, but my equation predicted them to be no. So you can see that this is pretty bad when you use linear regression for data class like this. Now, here is the most interesting part. Imagine you can draw a line like this. This is much better fit compared to the previous linear equation that we had, okay? And here, when you draw a separation between using 0.5 value, you can clearly say that this model works much better than the previous one. The question arises, what is this line exactly? And how do you come up with this, right? If you have learned statistics, you might have heard about sigmoid or logit function, and that's what this is. Okay, now the moment you hear this term sigmoid, you might pause this video and start Googling about sigmoid, and it is fine. You can read all the articles. About sigmoid or logit function to get your understanding correct on mathematics behind it. But if you don't want to do it, I will give you a basic idea. The sigmoid functions equation is 1 divided by 1 plus e raised to minus z, where e is some mathematical constant. It's called Euler's numbers. The value is this. Now think about this equation for a moment. What we are doing here is we are dividing by 1 by a number which is slightly greater than 1. And when you have this situation, the outcome will be less than 1, correct? So all you are doing with this sigmoid function is coming up with a range which is between 0 to 1. So if you feed set of numbers to the sigmoid functions, all it will do is convert them to 0 to 1 range. And the equation that you will get looks like S shape, right? So if you plot a 2D chart, it will look like S shape function that we saw in the previous slide. Essentially, what we are doing with logistic regression is we have a line like this, which is linear equation. And you know the equation for our linear line, which is mx plus b. All you're doing is you are feeding this line into a sigmoid function. And when you do that, you convert this line into this S shape. Okay, so here you can see that my z I replaced with mx plus b. So I applied sigmoid function on top of my linear equation. And that's how I got my S-shaped line here. All right. Now, all of this math is just for your understanding. As a next step, we are going to write logistic regression using sklearn library. And these details are abstracted for you. So don't worry about it. You don't have to implement all of this mathematics. You will just make one simple call and it will work magically for you. All right. So let's get straight into writing the code. Here is the CSV file containing the insurance data. You can see there are two columns, age and whether that person bought the insurance or not. And we are going to import this into our pandas data frame. So I have loaded my Jupyter notebook by running Jupyter notebook command on my command line. I imported a couple of important libraries, and then I imported the same CSV file into my data frame, which looks like this. And now I'm going to plot a scatter plot just to see the data distribution. And you can see that I get a plot like this. Here, these are the customers who didn't buy the insurance. These are the ones who bought the insurance. And you can see that if the first thing now we are going to do is use trained tests. You like important libraries, and then I import just these are the ones who bought the insurance. And you can see that if the person is younger, he's less likely to buy the insurance, and as the person gets older, he's more likely to buy the insurance. The first thing now we are going to do is use train test split method to split our data set. So if you look at our data, we have 27 rows. So we are going to split these rows into training set and test set. Again, I have a separate tutorial for how to do train and test split, so you can watch that. It is basically from sklearn model selection, you import train test split method. Here my x is df age now array, so I'm just is y, and I will say what is my test size. If you want to see the arguments, you can do shift tab and it will show you a help for this function. So I use this a lot, it is pretty useful. So let's see. So there is this test underscore size parameter, so let's use test underscore size. We are going to do, or let's say train size, right? So training size is 0.9, so 90% of the example we are using for training, and 10% we will use for actually testing our model. Now what do you get back as a result? So these are the things you get back as a result. So I'm just going to copy from here, and that's it. Hit Control Enter to run it. Okay, so here there's some warning. Maybe they are asking us to use test size. Doesn't matter. Okay, let's look at our test. So our test is 18, 23, and 40. So these are the three values we are going to perform our test on. When you look at our X train, these are the data samples we will use to train our model. Right? So let's now import logistic regression. So from same linear model, you can import logistic regression. sklearn. All right, so we will have logistic regression class imported, and we are going to create an object of this class. We will call it a model. Fit you are actually doing in, this is what you use for your training. When you execute this, this means your model is trained now and it is ready to make predictions. So for these three values, we are making test. So it is saying these two customers are not going to buy your insurance. And you can see that it's kind of working because they have age of 18 and 23-year-old. And we saw that as the age is, the younger age people do not buy the insurance. Whereas I think anything more than 27, 28, they buy. So here the age is 40. So the answer was 1. Okay. If you want to look at the score, score is nothing but it is showing the accuracy of your model, right? So what you're doing is you're giving X test and Y test, and here the score is 1, which means our model is perfect. Now this is happening because our data size is smaller. We have only 27 samples. But if you have more wider samples, then it will make mistakes in at least few samples. So your score will be less than 1, right? Because of the small size of our data set, the score is pretty high here. Another method to try is you can see that when you hit, by the way, tab, it will show you all the possible functions that start with teddy. Okay, so here you can also predict a probability. So when you predict a probability of X test, it will show you a probability of your data sample being in one class versus the other. The first class here is if customer will not buy the insurance. So for the age 18 and 23, you can see there's 0.6% probability that they will not buy the insurance. Whereas for the person with age 40, it is reverse. There's 0.6% probability that he will buy the insurance and 0.39% probability that he will, not 0.39% really, it's really 39% that he will not buy the insurance. If you want to do one off, then you can just do model.predict 56 0. So this model that we built is what you know about Kaggle website. This is the website that hosts different coding competitions. You can even search for data sets. So if you want to do some Titanic data analysis, you can search for that. I have downloaded this HR analytics data set where there is an analysis on the employee retention rate or employee attrition, is the number of projects or average monthly hours that person has worked on. You are trying to establish correlation between those factors and whether person would leave the firm or whether he would continue with the firm. These kind of analytics are very important for HR department because they want to retain the employees, and if employees don't leave the firm. So that's what you're going to do. You are a data scientist. You're going to work for your HR department and give them a couple of things. So I have mentioned all of those things in the Jupyter notebook, which I have available in the video description below. And you want to download it the same level as the answer on these 5 questions. Okay. First one is, out of all these parameters that we have, you want to find out which factors affect the employee retention by doing some exploratory data analysis. You will also plot bar charts showing the impact of employees' salaries on retention, and then using the factors that you figured in step 1, prediction in the answers. And if you want to verify the answers, then I have a separate notebook directly. Okay, a good student